Okay, good afternoon. Again, today we are going to continue the fourth unit. What is the name of fourth unit? Fuel and combustion. As I told you earlier in previous lecture, this unit divided in two parts. First part is the fuel and second part is the rear combustion. Yesterday we have discussed about the definition of fuel, chemical definition, chemical fuel. What do you understand by chemical fuel? Anyone? Yes, tell me.
The of oxygen is providing fuel, providing fuel energy, and a
A chemical fuel is defined as the total amount of heat liberated by the complete combustion of the fuel in presence of sufficient amount of oxygen, and the liberated heat can be utilized, can be used for domestic as well as for industrial purpose. After that, we have discussed the units of calorific value. Before that, we have discussed the calorific value. Calorific value decides the rank of the coal, which type of coal we are using. Okay, anyone of you can define the calorific value? What is calorific value? It is the total amount of heat liberated when total amount of heat liberated when unit mass or unit volume of the fuel is completely burned. And okay, then after we have discussed the types of calorific value. There are two types: gross calorific value and net calorific value. What is gross calorific value? Gross calorific value, and in short it is written as GCV. How can you define? Total amount of heat liberated when unit mass or unit volume of the fuel is completely burned and the product of the combustion is allowed to keep at room temperature. Okay. After that, we have discussed the net calorific value. In short, it is written as NCV. What is net calorific value? Net amount of heat liberated when you are burn the coal. Yes. Okay. Net amount of heat liberated when you are burn the unit mass or unit volume of the fuel completely, and the product of the combustion is allowed to keep at atmosphere. I have given one example for this. The example for this one is, suppose you are burning the hydrogen in the presence of sufficient amount of oxygen O2, and you are getting the H2O plus delta H, that is heat. Okay, what is H2O? H2O is the oxide of hydrogen. Any element which you are going to burn in the presence of oxygen, that is converted in the its oxide form. As you know, hydrogen gas is the renewable source of energy, and there is a no pollution after the combustion. This product, what is this? H2O. H2O in the form of the vapor. steam. And the first case, it is totally conserved in the system, and the second case, NCB, in the case of this water vapor is allowed to escape in the atmosphere. Today we are going to discuss the relationship between GCB and NCB. Write down relationship between GCB and NCB. So, according to statement of, at the further statement of, you can say the definition of GCB and NCB. NCB is equal to GCB minus latent heat of steam. Latent heat of what is latent heat? It is a type of energy, heat energy, which is hidden, right? So, I told you, I have given the example of H2O. When you are going to burn hydrogen in the presence of oxygen O2, you are getting the H2O plus heat energy. Clear? When you are going to burn 2 gram of hydrogen in presence of 16 gram of oxygen, you are getting 18 gram of the H2O, water vapor. And when you are going to proportionate it, 1 gram of the hydrogen gas in presence of 8 gram of the, and you are getting 9 gram of the H2O. So what is the proportional? The proportionate is the 1:8:9. That means 1 mole of hydrogen corresponds to 9 gram of the H2O. Now you know the formula, how you are going to calculate latent heat by this formula. Q is equal to M into L. Right? What is M? M is the mass and L is the latent heat. So here you can elaborate this formula. NCB equal to GCB minus 9 into mass of hydrogen into mass of hydrogen into latent heat of steam. To latent heat. Now GCB minus 9 into, suppose we are going to consider mass of hydrogen. Hydrogen is represented by capital H into latent heat is given as its practical value, experimental value 588. 588. Again, this value is equal to GCB minus 9 into H divided by 100 into 587, 588. 5 we are going to divide hydrogen by 100. In your numerical problems, the hydrogen composition given in the form of percentage, so that for convenience you are going to put the directive value of hydrogen percentage in this formula. You don't want, there is no need of again conversion. Suppose in your numerical problem the hydrogen percentage given 70%, so that in place of hydrogen you are going to write them 70 directly. There is no conversion at all, right? There is no need of conversion. So that ultimate you are having the GCB minus 0.09 into S into 588 calorie per gram. So ultimate you should have the formula relationship between GCB and NCB. It is NCB is equal to GCB minus 0.09 into S into 588 calories per gram. Now we are going to discuss the determination of calorific value. Determination of